So I told you we're going to talk about hotspots, and that hotspots aren't exactly like volcanoes. I mean, they're related to volcanoes, but they're their own special thing, which is why I didn't want to lump it in with the rest of the volcano talk. Hotspots are not near plate boundaries. They're actually in the middle of plates, and they force their way up through the crust, and I want to keep it separate because Japan has volcanoes because of the plate boundaries. Well, Hawaii is formed through hotspots, and they're not the same thing at all. So when magma goes up through it and eventually makes it to the surface, it becomes lava. You get enough of that, you start to form islands. Well, the plates are moving, as we know, and as the plate moves in new directions over this hotspot, well, new islands are going to form. But the old ones, those volcanoes, are going to become extinct. What does that mean? Well, an active volcano is one that's currently erupting, and a dormant volcano is one that can erupt and has erupted, but hasn't erupted in a long time. An extinct volcano is no longer connected to its magma source. It cannot erupt again. It's not like it's been a long time, so it cannot erupt again. So Hawaii has a mix of extinct and dormant and active volcanoes. And active volcanoes are what are building the latest island. And eventually it's going to be a new island. So as we go over this hotspot, we start to see the island grow and grow and grow in size. And as the years and years and years go on, the weathering and erosion will eventually weather and erode them away. And they'll become smaller and smaller and smaller. So take a look at what Hawaii looks like. And we're going to do that together here in just a little bit. And we're going to figure out, well, which way is the plate moving? Well, it's probably the direction that the smaller one is the oldest and the largest one is the newest, and that's exactly what we see. Now, I don't know if I talked about tsunamis at all in this notes packet or not. I may have taken it out. I can't remember off the top of my head, but I'm going to go ahead and talk to you a little bit about them. Tsunamis are when a lot of energy is released underwater. This could be a volcanic eruption. This could be a giant landslide. This could be an earthquake. Well, this water then goes up and pushes the water up, but the water has to come back down somewhere, and it comes back down. As it spreads, as it radiates from that center thing, if you want to think of it kind of like the epicenter of an earthquake, you could think of it like that, but it's the water surface rather than the land surface. Well, the energy's got to go somewhere, so it starts going through the ocean. This goes sometimes at hundreds of miles an hour as it originally starts. Now, it's going to slow down as it makes it to the shore. The energy is going to dissipate, of course, but it originally can go very quickly. Here's some things you need to know about tsunamis, though. When you're at deep, deep ocean, you probably could just, and people have, taken a boat and go over a little bump. The ocean's so deep that the energy travels through the entire depth of the water, and it never really looks like anything. It's maybe a 2 or 3 foot wave, and people just, took their boats or ships over a tsunami. Not that big of a deal. As it gets closer to the shore, that's when problems start to happen. Well, first things you need to know, and this actually saved the life of a bunch of people in that Boxing Day, so December 26th, if you don't know. Tsunami back in 2004 I think it was India. It was in the Pacific Ocean for sure, in that area. If you're at the beach ever, and you see the water start to recede and recede and recede and recede, and I'm not talking low tide, I'm talking this is weirdly away from the shore, I would get away quickly and get to high ground as quickly as you can. What's happening is all that energy is moving through the water, and it has to go somewhere, but it can't go through the depths of the water anymore. So it starts pulling the water back as the tsunami starts to get closer to shore. And I'll show you a video of this. Well, if it can't go depth anymore, it now becomes height. But it's not necessarily what you're thinking of. And let me make this clear. Tsunami and tidal wave are not synonyms for each other. They're two different things. Tidal waves are tides that's affected by that. It just happens to be a really large wave. A tsunami is something completely different. And sometimes tsunamis aren't that tall. They can be only 10 or 12 feet sometimes. And they can get up to like 100 and 150 feet, but sometimes they're not that large, but they take up the entire width of your field of view. And it's just relentless water making it onto the shore, one wave after another after another. That's where a lot of the flooding comes in, and that's where the deaths happen. People see that the water is receding, they start to go investigate it when really they're going towards the water. They need to be getting away from it as quickly as they possibly can. The water goes in and it just stays there, and more water comes in and it stays there, and it floods and it floods and it floods. And if you're not on top of a building or a really high ground, the water is going to stick around for a while and it's not going to get better. And unfortunately, when that rip current starts getting pulled back into the ocean, when that water starts receding back to its normal level, it's going to do that damage again in the other direction. And if you've not taken those proper precautions and you've not stayed safe, that's when a lot of people are going to get pulled by debris or get knocked out by debris or get, pulled underneath because they're stuck underneath a car, or they tried to run away in their car and they're stuck. That's when you really get your deaths, unfortunately, with tsunamis. They're not like you can predict them like a volcano and you see the smoke. It's kind of like an earthquake where it happens and that's what you got to do. Now, these are exciting to learn about, but they can, unfortunately, and as we're going to talk about in weather, even though it's really exciting and maybe it's interesting to you from a scientific perspective, we have to keep in mind the other side of this, that people can be seriously injured or unfortunately killed when we go through them. And when we get to tornadoes and earthquakes and storms, they might be really fun and exciting to learn about, and you might like watching videos of really big tornadoes going through places, but just remember, you're lucky that you're getting to watch the video of a tornado going through someplace and you weren't where the tornado was going through. Same thing here. That's pretty much the end of the lithosphere unit. Please start reviewing if you haven't already. I hope you have. I've tried to give you enough time to do it. Get ready for your quiz. Ask any questions you have. We're going to review in class as soon as I get to see you again. And, well, good luck.